In this video, we're going to learn about units and metric conversions. So, in science and the physical world, there are 7 base units, and these are the units of mass, which will be kilogram. The unit that measures length is the meter. Temperature is the Kelvin. The amount of a substance, meaning like the number of molecules, not the mass of them, but rather just the number of the molecules, for example. That is the mole. Electrical current is measured in amperes. Time is measured in seconds. And luminous intensity, basically how bright light is measured in the candela. And what's kind of amazing is that from these base units, anything else can be derived. So derived units are measurements that are a combination of the base units. And probably the simplest one is area. Well, area we know as length squared. And so we can take the meter and square it, and that's our area. Volume, a derived unit would be meters cubed. For speed, we'd have meters per second. And for energy, we have something called the joule, which is actually an abbreviation for kilograms times meters squared over seconds squared. Pretty strange, that one. I'll leave that for physics. Oddly enough, it is energy. But let's go back to area. I'm sure in math classes you've seen before area expressed as centimeters squared. And what's up with that when meters squared would be the SI unit? Well, we have these prefixes that can be useful for scaling SI units. If you have something with an area of 5 meters squared, 5 centimeters squared, if you were to convert that to meters squared, the number would be a little bit less comfortable to work with, perhaps. So instead, we're going to use centimeters squared. What is a centimeter? Well, centi, the prefix centi, means 10 to the negative second. And we can see it right here. 10 to the negative second is centi. So we have 0.01 of whatever it should be. In the case of centimeter, it's a centimeter, so it's 10 to the negative second meters. If we had 2 centimeters, it would be 2 times 10 to the negative second meters. Things that you're probably familiar with that you've seen before, centi, milli. You may have heard of nano, which is 10 to the negative ninth. You probably have also heard of kilo, which is 10 to the third, 1,000. Mega, you may and may not have seen. Giga as well, tera. These are commonly used in computers. Gigabytes, terabytes, for example. Megahertz, well, gigahertz by now. And again, these are just ways to scale units. So here's a problem. If you want to walk from Concord Center to Boston Common, that's going to take you, you're going to have to go 28.8 kilometers. So if you wanted to convert this to centimeters, you'd be getting quite a bit more centimeters than kilometers. Here's how you do the conversion. We have 28.8 kilometers. 28.8 kilometers. And we're going to have to multiply this by some conversion factor that gets us to centimeters. Off the top of my head, I'm not entirely sure how many centimeters are in a kilometer, but I do know that kilo means 10 to the third. It means 10 to the third. So we would say that 1 kilometer is equal to 10 to the third meters, or I could just write 1,000 meters. And I also know that 1 meter equals 100 centimeters. And that I didn't even need to look up. You knew this as well. Cent, 100, right? So 28.8 kilometers, and I'm going to multiply it now by this first conversion factor, which and need to turn into a fraction, what I can say is that this is times 1,000 meters for every 1 kilometer. It's important that you get this right, that the meters are on top and the kilometers are on the bottom, because, well, two things. First of all, the numbers work out. You have more meters if you're multiplying by 1,000. You have more meters than kilometers. A meter is small, so there should be more meters per kilometer. The other thing is that if you look at it mathematically, we have the kilometers canceling each other, and our new unit is meters. Kilometers times meters over kilometers, just as meters. But we're not quite done yet, because actually we're at meters and we need centimeters. So I'm going to say that there are 100 centimeters for every 1 meter. I'm just taking this conversion factor, this reality that we know, and I'm turning it into this fraction. The meters cancel out and we get centimeters, and so now all I need to do is just the arithmetic, multiplying 28.8 times 1,000 times 100, dividing by 1 times 1. We have 2,880,000 centimeters are in the 28.8 kilometers, and that's it. I could have done this in one step if I did know that the conversion factor, let's see, 1,000 times 100 would be 100,000. So what I could do is I could say, if I did know this, I could just add the exponents, basically, like 1 kilometer equals 10 to the third meters, and 1 meter equals 10 to the second centimeters. I could say that 1 kilometer is equal to 10 to the fifth centimeters. Nothing wrong in figuring this out first, just from the fact that we have 10 to the third and 10 to the second, so we need 10 to the fifth. And then using that as my conversion factor, 28.8 kilometers times 10 to the fifth centimeters over 1 kilometer. Oops, 1 kilometer. I'll just say km. Sorry about that. 1 km equals 2,880,000 centimeters. We'll learn about scientific notation in a video that's coming up soon. Anyway, for now, you have how to do metric conversions. Again, you really need to focus on understanding this chart, knowing what hecta is, what peta is, what micro is, etc., and how they can be used to scale the units. Then from there, it's just a little bit of math. Hope this video has helped. Let me know if you have any questions and comments in the comment section. Thank you.